Welcome students for the online lecture on elements of civil engineering and engineering mechanics. So in the previous lecture we had discussed about what is Varignon's theorem. So today we will be applying the Varignon's theorem to find out the resultant. So let us start with a numerical example. So this is the numerical example which we have considered. Say, I will read the question for you. Find the magnitude, direction and the distance of the resultant from the point A for the system of forces shown in the figure. So this is the figure. A, B, C, D are the points and there are forces acting on it. So let us start solving the numerical. So first, count how many number of forces are there. So we have 1, 2, 3 forces and the fourth one is a moment. So in total we have 3 forces and a moment. Now let us resolve these inclined forces into the horizontal and vertical component. So this component will get resolved in this direction, this will get resolved in this direction, this will get resolved in this direction. So in total we have 6 forces now and 1 moment. So let us start solving the numerical. So the first step is to calculate summation of f of x or summation of horizontal. So remember, we are solving x component and we are taking cos component. So if we are taking for the f of x versus cos component, then the angle should be with respect to x. So this angle for this force is with respect to y. So I will convert it into with respect to x. So it is 30 degrees here. This with respect to x will become 60 degrees and this is with respect to x. So let us start solving. So summation of f of x. Let us start with this force. So this is the first force. So this will be going, it is going forward, so it is positive. So I will write the sign convention. So forward is taken as positive. So this is 60 cos of 30, which is positive. Then this also positive, plus 45 cos of 60 degrees. Then this one minus 75 cos of 45 degrees. So let us solve and check how much is this. So this is working out to be 21.428 kilonewton. So it is positive, that means it is going forward direction. Similarly, we will find summation of f of y, that is summation of vertical, which is nothing but upwards is assumed as positive. So let us check. So we have this going upwards, so positive, so plus 60 sine 30 degrees. Then we have this minus 45 sine of 60 degrees. Then we have this minus 75 sine 45 degrees. So let us check how much it works out to be. So it is working out to be minus 62.004 kilonewton. So negative in the sense means it is in the downward direction. So we got this. Next is to find out the resultant. Resultant R is nothing but summation of f of x square plus summation of f of y square and under root. So it is nothing but 21.428 square plus 62 square. So resultant R is 65.598 kilonewton. We will find theta also. So tan inverse of summation of vertical divided by summation of horizontal, which is 62 divided by 21.428 tan inverse. So the angle is 70 degree. This is nothing but tan inverse of 62 divided by 21.48, which is 70.94 degrees. So now we have computed resultant and the angle. Now let us compute the movement. Now in the question what they have said, find out the distance of the resultant from the point A. That means this is the point A. So we have to take the movement about A. So I will write movement about A. So here movement will take clockwise as positive. So I will write it as summation of movement about A. So what is the movement about A means? So bring all the forces to the point A. So let us start with this. So we have this as a horizontal force. So what is the movement? Force into perpendicular distance. So this force will not have any perpendicular distance, so this will not contribute. This force will have a perpendicular distance, so it will go in a anti-clockwise direction. So it will be minus 60 sine 30 degrees. This is the force into perpendicular distance. So this is 2 meters into 2 meters. Then this is the next. So the horizontal force is there. So this will be going in clockwise direction to reach at this point. So this will be plus 45 cos 60 into to reach this point. So this distance. So into 3. Next is this downward. So this also will go anti-clockwise. So this will go clockwise. So this will be 45 sine of 60 degrees into 2 meters, because this will reach here and then it will go. Then we have this moment. This is already a clockwise. So this is plus 100. Then this coming to this. So vertical component will not have any perpendicular distance, so it will not contribute. So this horizontal, so this is going in this direction, so it will come in anti-clockwise direction and reach here. So minus of 75 sine 45 into 3 meters. So these are the components. So let us compute this, how much it works out. So this is working out to be 146.34 kilonewton meter, because this movement is nothing but force into perpendicular distance. Now as we have already discussed about the Verringen's theorem, so what does the Verringen's theorem says to find out the distance of the resultant? So we have found out the summation f of x, summation f of y, resultant, theta, and we also found out the movement about A, because in the question they have mentioned that resultant of the point A. So this is the movement about point A. So it is in the direction clockwise direction because it is positive. Now next what we have to find out, we have to find out at what location it will be placed. So this resultant where will be it placed? So we will compute. So applying variance theorem, which is nothing but moment about A is equal to R into X. So we already have a moment about A. Moment about A is 146.34 and R is 65.598. This is a moment and the resultant R is 65.598. So we will substitute this both in this. So it is 146.34 equal to 65.598 into distance x. So we want x. So x is equal to 146.34 divided by 65.598. So this will be 2.23 meters. So the distance of x is 2.23 meters. So applying variance theorem, we got the moment and we got the distance. So what they have said, find the magnitude and direction and the distance of resultant from the point. And now it is that we have to locate the resultant. You already know that the summation of f of x is forward, summation f of y is downward. That means it is like this. So this is summation of f of x and summation of f of y. This is forward, this is downwards, and the resultant will lie here, making an angle. So this is what we have. And what is the distance we have calculated? 2.23 meters. This distance is from where? Distance from point A. Now locating the resultant. So from point A, it will be drawn a perpendicular and the resultant will be placed. So resultant will be like this. So this is the resultant. As in case you can see, this I have just taken it from here resultant, and as it is I have placed here. And this is the distance x, which is 2.23 meters, which will be perpendicular, and this is the resultant r, which we have calculated. R is 65.598 kilonewton. So what all we have done initially? So a numerical will be given, which will have forces and the moments. First you have to find out summation f of x, summation f of y. Please make a note, this is a movement, so this won't be considered in these two calculation. So only horizontal and vertical. Now how many number of inclined forces are there? Resolve it, find f of x, find f of y, find the resultant, find the theta. And in the question they will be mentioning at what point. So at that point find out the moment about all the forces. And then applying variance theorem, you find out the distance x for the location of resultant from the point A. So once we have got, you have to represent the resultant graphically here. So this is nothing but the distance x which we have calculated, and this is the resultant. How will you find whether this resultant is going in this direction or above direction? It depends on this diagram. As summation f of x is forward, summation f of y is downward, so resultant is lying here. So we have to just pick it up and place it, and it should be placed at a distance of so much, so that it is completed. So this completes the numerical on the variance theorem. In the next lecture we will solve one more numerical on the variance theorem. So all my students, please stay home and be safe. Thank you.